Okay, this lesson is on dividing polynomials. It is section 5.4 out of our textbook. We're going to use the traditional long division algorithm that I hope you all learned in elementary school. And we're also going to learn a new method called synthetic division. So, to start off with, I would like to review what you've done in elementary school. So hopefully you remember. And why my thing's not working? There it is. Let's see if that doesn't get fixed real quick. Okay, so the first step is you always divide. Okay, when you're looking at something like this, when you're dividing, if I go to a simpler one, you divide 3 into 5, and 3 goes into 5 one time, and then we multiply those two outside numbers. So 1 times 3 is 3, and then, hope you remember, you do subtract. So 5 minus 3 is 2. And after we subtract, we bring down. And then you just start that process all over again. So if you don't remember this from elementary school, please come see me, and I'll be happy to go over that with you some more. As I finish this problem, 3 goes into 22. 7 times 3 is 21. 22 minus 21 is 1. So this one would be a remainder of 1. If I do, when you get bigger, 42, we say 42 into 56. Excuse me, into 54, because you start off doing it. And I do 2 digits because I want to remind you, 42 doesn't go into 5, so I don't write anything on top of the 5. But 42 goes into 54 one time, and then I do 1 times 42, which is, of course, 42. And then I subtract, and 54 minus 42 is, well, 4 minus 2 is 2, 5 minus 4 is 1. And then I bring down my 6, and 42 goes into 126, I'm thinking 3 times, and we do 3 times 6. Okay, so this is kind of something more what we're doing. You're going to do 3 times the first number, which is 6, and 3 times that second number, which is 40 or 4, and that's 12. And then you subtract. So this time I had a remainder of 0. And if it has a remainder of 0, then we say 42 goes into 546 evenly, or we say 42 is a factor of 546. And let's review this. The answer to a division problem is called your quotient. Okay, this number on the outside is called your divisor. And this number, we don't actually need to know that one as much. This is your dividend in case you're curious. And of course, these two numbers right here are what we call the remainder. Okay, so 42 goes into 546 13 times. That means 42 is a factor of 546. So keep that in mind because we're going to come back to that. Over here, 3 is not a factor of 52 because it doesn't go into 52 evenly. But I also want you to realize that this, when you write this answer, you can write it remainder of 1. But it's also, if you think of 52 divided by 3 or over 3, then that answer is 17. And then we say remainder of 1, and we write that over the divisor. So again, that's something else that we're going to keep in mind as we go through this lesson. Okay, so let's look at what we've got to do, some examples. Use polynomial division to divide 3x squared minus 29x plus 56 by x minus 7. What is the quotient and what is the remainder? Okay, so when you're doing this problem, please make sure to line up your like terms, and you're going to see that as I go through. And I did it with the numbers just up above, but it will really help you keep everything straight when you're doing this problem. So this is your dividend, this is your divisor, so we're writing that on the outside, x minus 7. And I'm going to divide 3x squared minus 29x plus 56. And so x goes into this number, and some people have trouble with this. X goes in, I don't know how many times x goes into it, so I think of it as x times what number gives me that. Okay, if that doesn't help you either, you can come over to the side and say, how many times does x go into 3x squared? So come over here and divide it. And when you divide that or simplify it, you'll find out that you get 3x. So that's actually what's going to go up here. And when I say line up your like terms, I want you to line it up on top of the x term, because that will help you know when you're finished. Don't put the 3x on top of that because those aren't like terms. These are like terms. And now, so that's our dividing. And now I've got to multiply. So 3x times negative 7 is negative 21x. 3x times x is 3x squared. And your goal is to always have these two exactly the same. Now, the next thing we do is subtract. And I really prefer that you write it like this, because when people go minus plus, they start changing all these signs and then they make mistakes and get the problem wrong. So hopefully you put parentheses around it, put your minus sign. Those will always cancel. So now I have negative 29x minus a negative 21x. So that's negative 29 plus 21, which is going to be negative 8x. So I subtracted, and now I'm going to bring down my 56. And I'm going to say x times what gives me negative 8x? That's going to be minus 8. Again, I'm lining up my terms. And like I said, if you want to come over here, negative 8x divided by x. Okay, that's the dividing part that you're doing if you need help with that. So you get minus 8, so that's what I wrote, minus 8. And I'm multiplying. Negative 8 times negative 7 is positive 56. Negative 8 times x is negative 8x. And again, those two need to be the same. And if you look at this, these are the same also. So when you have something and you subtract it out, you're going to be left with 0. So they asked us what is, here's basically the answer to the problem, but they want us to identify what is the quotient. Remember, the quotient is the answer to your division problem. So this is the quotient. And what's left here is your remainder. And we have a remainder of 0. All right, let's look at another one. We have x squared plus 1. They want to know, they're asking us, is x squared plus 1 a factor of this nice polynomial? So, to do this problem, again, I'm going to divide. Because how do I know if something is a factor? We talked about that up here. It's a factor if when I divide it, the remainder is 0. Okay, so that means this right here, let me go write that so you can go back and look at it. That means this right here is a factor of the dividend, okay, because my remainder was 0. So that means we're going to go divide this, and we're going to see if we have a remainder of 0 or not. So x squared plus 1 into 3x to the 4th minus 4x cubed plus 12x squared. Oh, look here, y'all. They go 4, 3, 2. There's no 1. So if you're missing an exponent when they go in order like that, you have to put in a placeholder. So we just write 0x. Okay? So now I'm going to divide. Um, and x squared times what is 3x to the 4th? Again, I'm going to change each time I do one. So this is 3x to the 4th over x squared. And that, of course, is 3x squared. So I'm going to write 3x squared, and I'm going to go put it on top of this one because I want to line up my like terms. And now I'm going to go multiply. 3x squared times 1, oh, that's 3x squared, lining up my like terms. And 3x squared times x squared is 3x to the 4th. And that's, of course, positive because there was no negative. And I'm going to subtract these. So when I subtract, those are the same, goes away. I'm going to carry that down because basically I'm subtracting zeros. So this becomes negative 4x cubed. 12 minus 3 is 9x squared. And then I bring down my next term, which is 0x. Okay? So now I'm doing x squared into negative 4x cubed. So negative 4x cubed divided by x squared. I hope you can see that that is negative 4x. So I'm going to write negative 4x. And now I'm going to multiply negative 4x times 1, which is negative 4x. Negative 4x times x squared is negative 4x cubed. And now I'm subtracting. I'm subtracting that thing. These are the same, so when I subtract them, they go away. 9x squared is going to be carried down because I subtracted 0 from it. 0 minus a negative 4x is, of course, plus 4x. And then I bring down my last term. So I bring down my 5. And let's go with, what do I multiply x squared to get 9x squared? I hope y'all can see that one. That's a pretty easy one. That's 9. And so 9 times 1 is 9. And 9 times x squared is 9x squared. So I subtract. And my x squareds go away. My 4x carries down. And 5 minus 9 is negative 4. Okay? So this right here is my remainder. So if I have a remainder, is this a factor of that? And I hope y'all can see the answer there would be no, it is not a remainder. Okay? I mean, excuse me, no, it's not a factor. Okay? Now, so basically what we've just, well, there's another way of doing it besides long division. And we have this thing called the factor theorem that tells you if you take a value and you plug it into the polynomial, and when you plug it in, you get 0, then the resulting factor, which is x minus a, that's coming from the chart that we've talked about in earlier sections, is a factor of the polynomial. Okay, so this is basically what we've been doing, but writing it mathematically. But let's go see again how it's applied. Okay, so look at this problem here that says, is x minus 2 a factor of this polynomial? Okay, so the factor theorem that we just talked about, okay, if it's a factor, then what is the related root? All right, remember this is what we did. The related root is going to be x equals 2. So if I go plug in 2 into this right here, p of 2, and I get 0, then I know it's a factor. That's what that theorem says. If p of a equals 0, then x minus a is a factor. So we're going to go put in 2 to the 5th minus 32. Okay? Does that equal, what does that equal? Well, 2 to the 5th is 32, and 32 minus 32 is 0. So that means, yes, x minus 2 is a factor of that polynomial. So sometimes it's easier when we do these things to find out whether or not something's a factor before I actually do the division. Now, unfortunately, they've asked us to, since it is, we have to write p of x as a product of two factors. That means I got to go divide this out. So I have to go do x minus 2 into this polynomial. Okay, and the reason I extended it because I know I have x to the 5th, and I don't have an x to the 4th, and I don't have an x to the 3rd, and I don't have an x squared, and I don't have an x, and then I have a 32. So you can see how long this is. Okay, so x times what equals x to the 5th? I hope you all said x to the 4th. Okay, um, x to the 4th times negative 2 is going to be negative 2x to the 4th. And x to the 4th times x is x to the 5th. So I multiply, I subtract, and these cancel, and 0 minus a negative 2 is positive 2x to the 4th. And then I'm going to bring down 0x cubed. And I'm going to say, what do I multiply x by to get 2x to the 4th? And that, of course, is 2x cubed. Okay, if you're still having trouble with that, do it like we did the earlier problems, or come see me. 2x cubed times negative 2 is negative 4x cubed. 2x cubed times x is 2x to the 4th. And I'm going to subtract that. First terms cancel. All right, I have 0 minus a negative 4. That is positive 4x cubed. And I bring down my next term. And I have to say, what times x gives me 4x cubed? And it is 4x squared. See, remember again, my terms are lining up like we've talked about. 4x squared times negative 2 is negative 8x squared. Negative 8x squared, and then 4x squared times x is going to be 4x cubed. and I'm going to subtract those. And when I subtract them again, first terms cancel. 0 minus negative 8 is positive 8x squared. Bring down my x term. And what times x gives me 8x squared? And it's 8x. 8x times negative 2 is negative 16x. And 8x times x is, of course, 8x squared. And I hope I get this done before I run out of space. So I subtract those, boom, boom, they're the same thing. 0 minus negative 16 is 16x. Bring down my next term is 32. And I'm back at the beginning here. X times what is 16x? And that, of course, is 16. And 16 times 2 is negative 32. 16 times x is 16x. So you can see that we have the exact same thing, and my remainder is 0. Okay, so what this did, y'all, let me see if I can make this any smaller. Probably not. Anyway, let's go with that. So I have to write it as a product of two factors. Let me go see if I can do this one. Make this guy smaller so I have some room. Okay, I have to write it as two. Oh, then my little thingy doesn't work out. There we go. Um, I have to write it as a product of two factors. So to write that answer, okay, there's one factor. So p of x is equal to x minus 2 times x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16. So now I have written it as product of two factors. Okay? Now, you can understand that this is a very long process and could take a long time. So we have this wonderful thing that we can do in math, and it is called synthetic division. Okay? And what it enables us to do is it simplifies the process of long division only if your divisor is linear, and then y'all all know that means that exponent on it is 1. And we simplify this process by writing the coefficients only. Okay? Um, I'm going to do this for you really quickly with this guy right here. Okay? If I took this right here, and what you would do is I'm only going to write the coefficients, and I write the factor. So over here I start off with, and I write the factor of 2. And then I just write these coefficients. So that's 1, and how many? 1, 2, 3, 4 zeros. So 1, 2, 3, 4 zeros, and then the last number of 32. And what's going to happen is I'm going to do division in this process. Just watch, and I'll give you the more steps again. But what happens is I bring down the 1, and then I multiply 2 times 1, and I get 2. And then I add 0 plus 2 is 2. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. 0 plus 8 is 8. 2 times 8 is 16. 0 plus 16 is 16. And 2 times 16 is 32. And negative 32 plus 32 is 0. And this number, when you do this process, is always your remainder. So I don't know if you can see, but basically these are the coefficients going down, 2, 4, 8, and 16. Okay? So we're going to do that a little bit more, but you can now see that this is a little bit easier to do and more fun to do than that process. But it's important to be able to do this process because you cannot always use synthetic division. Okay? So here's an example right here. If is x to the fourth minus 1 a factor of that polynomial? Okay, well, how do we know if it's a factor? We can figure out what that would give us. And one of the zeros, okay, that we just did yesterday, if I took this guy, x to the fourth equals 1. Actually, I told you not to do that, so let's don't do that. X to the fourth, I need to figure out what 0 that gives me. Okay, that's x squared minus 1 and x squared plus 1. And so that means x squared equals 1 or x squared equals negative 1. So what I'm trying to figure out is x equals plus or minus 1. So to find out if it's a factor, I need to go figure out what p of 1 is. It doesn't matter if you do 1 or negative 1. 1 is easier. So I go plug it in. Is 1, and what does it have to equal when I put it in there? We just talked about that's our factor theorem. If I plug 1 in and I get 0, then I know it's a factor. So I'm going to have 1 to the 5th plus 5 times 1 to the 4th minus 1 minus 5. Well, what does that equal? 1 plus 5 is 6. Minus 6 is 0. So yes, it is a factor. Is x to the 4th a factor? Yes, it is. Okay. If it is, write it as the product of two factors. Okay. So can I use synthetic division? Okay, I cannot because this is not linear. Okay. This one right here is not linear, so I cannot use synthetic division, and I have to go do it the long way. So that means I have to do x to the 4th minus 1 into x to the 5th, 5x to the 4th, plus 0x cubed plus 0x squared minus 5. Oops, nope, 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 nope. Plus 0x minus 5. Okay? X to the 4th times what gives you x to the 5th? Well, that's x. So I'm going to put it over here. And I'm going to multiply x times 1 is, or x times negative 1 is negative x. And x times x to the 4th is x to the 5th. Boom. Subtract. And that gives me those cancel. So I have 5x to the 4th plus, you really don't have to write those. Well, we will. Yeah, we do. 0x cubed plus 0x squared, and 0 minus a negative x is plus x. And I carry down my 5. Okay. X to the 4th times what gives you 5x to the 4th? Well, that, of course, is 5. Doesn't look like a 5. Okay, looks like a strange 5. Try that again. That's better. Okay. So 5 times negative 1 is negative 5, and 5 times x to the 4th is 5x to the 4th. So when I subtract those, what do I get? Well, those cancel, and those cancel, and those are 0. Oh, is it? 0, that's an x. It's not a factor. Oops, hold on one second. Somebody walked in my room. Okay, so I hope you finished yelling at me now because I missed something in the very beginning there. That says minus x, and for some crazy reason, I wrote that that was a 0x. Okay? And one of the ways that you can easily find those things out is because we said it was a factor. And if it's a factor, then that means your remainder is 0. So guess what happens when I do x? Oh, that's a minus x. I did not write minus x. Oh, Pooh Bear. Undo that. Let me go. I got to do smaller. Okay? This is a minus x. Okay? Because I didn't copy the problem down. Minus x, minus x. Minus x minus a negative x actually makes this guy down here a 0x. So plus 0x. So if you didn't get 0 here, you've done something wrong, okay? Because these cancel and these cancel and these are all zeros, so my remainder is 0. So to write p of x as a product of two factors, then p of x equals one factor is x to the 4th minus 1, and the other factor is x plus 5. So those are our two factors. All right, pause again. Okay, 3 more problems and we will be done with this lesson. So the next example that we have says use synthetic division to divide this polynomial by that polynomial. What is the quotient and the remainder? So we have now, can we use synthetic division? Yes, we can, because our factor of x minus 7 is a linear factor. So this is my factor, and if you can't remember what to put here in the box, what you do is you think of putting that factor equal to 0 and then solving, and what is the related root. That's that chart that we've talked about a couple sections ago. If x minus 7 is the factor, then 7 is the root, and that's the number that I'm going to put in there. Then I write my coefficients, making sure that my exponents go down by 1 without skipping anything. So I have a 1, That's x cubed. I don't have an x squared term, so I have to put a 0. That's x to the first, and that's, of course, your constant term. And I like to put a box here at the end because that's where my remainder always will be. Okay, and that's really important. We're going to talk about it again tomorrow. And remember, if that remainder is 0, then we know it's a factor. If it's not equal to 0, then we know it's not a factor. Okay, so the other thing that you want to keep in mind, well, first and foremost, the first thing that you do when you're doing this problem is you always bring this number straight down. Okay, that's how you start. And from there, whenever you're going this way, okay, you're going to multiply. And whenever you're going this way, you're going to add. I did that pretty quickly up above, but let me show you. So when I'm going diagonally, 7 and 1, I multiply 7 times 1, and I'm going to write the answer right here. 7 times 1 is 7. And then when I go down, I'm going to add. So 0 plus 7 is 7. 7 times 7 is 49. Negative 57 plus 49 is negative 8. 7 times negative 8 is negative 56. And 56 plus negative 56 is 0. And there's my remainder. Okay, so, excuse me, what is the quotient and what is the remainder? So when you write your answer of what the quotient is, okay, this original problem, this is a third degree. Okay, this right here is, actually, let me put that in a little bit different color because it's not really part of that problem. I'm just explaining things. Okay, so this, of course, is a third degree. That's what we've started with right here, third degree. So this polynomial right here is a third degree. Okay, that means this answer right here, it always goes down by 1 whenever you're doing synthetic division. So you want to remember that you always, when you're doing synthetic division, that answer, you always want to reduce your degree by 1 when you write that answer. So if I started with a cubic, I'm going to end up with a quadratic. So the answer to this is going to be 1x squared plus 7x minus 8. That is my quotient. Okay? And that's my remainder. We already said what the remainder was if you want to write quotient out there. Okay? Alright, hurry up because I don't want to be longer, too much longer. Alright, if the polynomial blah 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 expresses the volume in cubic inches of the box, then the width is that. What are the dimensions of the box? Okay? So if you knew the volume, you know the volume of a box is length times width times height. So that means I got to divide the x plus 1 into that thing. But again, I'm going to use synthetic division. And if x plus 1 is my factor, then I know that negative 1 is the related root. And I have 1x cubed, 6x squared, 11x, and 6. And I'm going to divide that. And so we always start by bringing down that first number. So that's a 1. Negative 1 times 1 is negative 1. 6 plus negative 1 is 5. Negative 1 times 5 is negative 5. 11 plus negative 5 is 6. Negative 1 times 6 is negative 6. And then I have 0. So that's good because we knew it was a factor. So basically what this gives us, this right here, is x squared plus 5x plus 6. And then I have that original x plus 1, okay, if you want to think about it. But I'm looking for the dimensions of the box. Okay, so I need to factor this. So this was the width, and this is the length times the height. So when we factor this, x, that carries down. X and x, the factors of 6 that add to give me 5. And that, of course, would be 3 and 2. So to answer the question, what are the dimensions of the box? It doesn't matter which one's length, width, and height. It does not. So we can say that the length is x plus 3 inches. The height is x plus 2 inches. And of course, we already knew the width was x plus 1 inches. And that's the answer to that question. A little bit abstract. Okay, last thing we got to talk about. The remainder theorem. I've been saying this to you all along so that we get to this problem, you'll understand what it means. But basically, when you divide a polynomial of a degree bigger than 1, which we always do, when you divide it by a factor, okay, and that factor that we've been using would be x minus a. That's like my x plus 1, or what I had up above that was x minus 7. So those are my two factors. So when you take a polynomial and you divide by the factor, then the remainder is always equal to p of a. And so you're kind of going, I don't really know what that means. So look at what happens here, okay? So when they do this right here, okay, and they say given this polynomial, it's a really long polynomial, what is the value of p of negative 4? So the long way to do it would be to put in negative 4 into this, but a lot of times people make mistakes. So what the remainder theorem says is I can actually go and divide negative 4 into that synthetically, because believe it or not, people make fewer mistakes. So I have a 1, I have a negative 3, then I have a negative 28, and a positive 5, and a positive 20. And this is what my remainder is. So I'm going to carry this down, carry me down my 1, negative 4 times 1, negative 4. Negative 3 plus negative 4 is negative 7. Negative 4 times negative 7 is positive 28. Add those, I get 0. Negative 4 times 0 is 0. 5 plus 0 is 5. Negative 4 times 5 is negative 20. And when I add those, I get 0. So this is my remainder. Well, that's what p of negative 4 is. That's what the remainder theorem says. The remainder theorem says whatever my remainder is, that's the value of the function at that point. So that's enough for me to say p of negative 4 is equal to 0. So when you have directions in your homework, it might say use synthetic division to evaluate p of negative 4 given that polynomial. Okay? So you've got lots of problems to practice. Please write down any questions that you might have and come see me if I can help. Thanks.